Hi, I'm Professor Isabel Lloyd. I'm the Undergraduate Program Director for Materials Science and Engineering, and I'm going to give you a short video tour of our Dieter Materials Instructional Laboratory. In this laboratory, the Materials Science and Engineering Department holds their 3-credit junior level lab class where they synthesize materials. So I'm showing you a hood. We process materials. So some of the processing we do is thermal. So we have a couple of furnaces. We can process them from organic precursors or from bulk materials, but changing their properties often requires thermal treatments. After we process materials, we need to characterize them. So in the materials 3-credit lab, one of the things we tend to do is we make zinc oxide nanoparticles, we process them, and then we characterize them in terms of their electrical and their optical properties, potentially also their thermal properties. If you look down that wing, we see a number of the different pieces of equipment that the students use in the lab, where they're looking at behaviors everywhere from the thickness of a very thin film using light, that's called electrometry, to nano indentation, where we can measure the elastic modulus and the resistance to penetration on a nanometer scale, to electrical and optical properties. So in order to give the students a good opportunity to understand the relationships between structure, and when I'm talking structure, I'm talking on the level from atoms to the level of nanometers and millionths of a meter, which is microns, all the way up to what you can see with your eyes, which we call mesoscale. We need to prepare samples, so we have a variety of equipment here to prepare samples for characterization and evaluation. We also have this lab when we do our mechanical properties class. It's important to understand the different kinds of mechanical properties in metals, ceramics, and polymers, and to understand how those properties are affected by structure at different levels. Here we have a mechanical testing frame. It's currently set up to use what we call a dog bone specimen, which basically think of your typical milk bone dog biscuit, and we can evaluate the strength of materials. We can evaluate the stiffness of materials. So that can be really important. We can also evaluate the energy that it takes to break a material. We call that toughness. That's really important when you're trying to develop materials for real-life applications. We can do those tests at room temperature and also as a function of temperature. We also have the ability to test materials in twisting or torsion, so that we can look at properties under a number of environments, because it's important to test a material you're going to use in an application under the same kinds of conditions that it would actually see in the application. Over here we have some more equipment. We have a hardness tester. Hardness is a really, really good technique to use for quality control in industry. It's not a fundamental property, but it's a really good way to see if the way you made a material is the way you intended to make the material and it has the properties you expect. We also have a variety of microscopes, because it's important for us to be able to characterize materials in terms of the size of their individual crystals. If you're thinking crystal, think about the diamond in a diamond engagement ring. That's a macroscopic crystal, and how those affect behavior. The next video you'll see should be of our advanced imaging and microscopy lab, where we can look at materials using electrons as our light source instead of visible light as our light source.